Chip Moore. Appreciate your being here all. We want to welcome our guest speaker here in a minute, but first I'd like to suggest that you get your calendars out for our next meeting, which will be coming up at let's see. That we're going first to Shelley's on April 19th and then to Sunny's on May 16th. Mike, would you do the honors of introducing our guest speaker today? And we'll get going from there. Our normal process would be running 45 minutes or so and then taking a 5-minute break, opening to question and answers for another 40 minutes or so. And then we'll go to open forum. For those who haven't been here before, thanks for coming. We appreciate it. And for those who have, you know what a treat this will be. Mike, our president, greetings.
Thank you, Chip. So welcome, everybody. Today we have a great honor for our Zoom meeting. We're going to be hearing from Dan D'Agostino. He's one of the legends in high-end audio industry. Most of you probably know he's founded 2 companies, Corel, and then later on, D'Agostino Master Audio Systems. Both of them spectacular companies with terrific gear. I still know of people in the society who have their Corel amplifiers from 30, 40 years ago and still running strong. And his new line of equipment is this beautiful stuff, very highly engineered and wonderful sounding. We awarded Dan the LA Orange County Audio Society Founders Award back in 2024. Very deserving recipient of that award. And we had a good time at the gala that year with Dan. And I'm really looking forward to hearing in more detail about some of his history and his companies and how he does things. And then we should have ample time for questions and answers in the second part of the meeting. I ask that all of you put your microphones on mute. You can put your video fade your video on or off as you wish, but make sure your mics are on mute until we open it up for the open forum questions. And as Chip mentioned, we'll have a brief break at around 3 p.m. our time, Pacific time, and then come back for Q&A and whatever else you'd like to find out from Dan. He's truly a man with tremendous amount of knowledge about high-end audio, and I'm sure he'd be willing to go as far afield as you care to take him. So let me turn it over to our honored guest today, Mr. Dan D'Agostino.
Hello, how are you guys doing? Well, let me start with we started, my wife Petra and I started Dan D'Agostino Master Audio Systems in, I believe it was 2011. And I had a lot of history at Krell making big, powerful amplifiers that got hot, got big, were very big. And I wanted to make something completely different and approach it from a completely different direction. The idea was to make something that really was physically beautiful, not big, but beautiful and powerful. And those two things actually are in contradiction of one another. Powerful normally means big. And I tried to figure out a way to do that. So I played with really good looking ideas, lots of different ones. My wife, who used to work at Rob Report, is really tuned into things that people like in luxury goods, that kind of thing. And she helped me a lot in saying, well, that doesn't look right, or I don't like this, or I don't like that. And let's not make an amplifier with too many buttons on it or fasteners. And so we started drawing, and I finally got to the shape. And all know what the momentum looks like. Those are like what I looked up to be like classic measurements. The weight, the width, the depth, and the height are all kind of a formula for perfect, they say perfect dimensions, perfect proportions. So I tried to stick to that. So this is the first time designing an amplifier. I made a box and then I decided to put an amplifier in it. And normally I would make the amplifier and then just put a box around it. So this was a different thought for me. And I wanted first because I wanted a beautiful structure and I didn't want it to be big, but I did want it to be powerful, and I did want it to have a lot of the things that I think are necessary for an amplifier: power, bandwidth, warm musical sound, easy to operate, good looking. All these things were part of my idea and my wife's idea. So I have to say that after I designed the amplifier, I said, wow, I'd like to put copper. I've never really worked extensively with copper. And so I decided to use a copper heatsink. So I had a couple amplifiers operating on perf board and big metal heatsinks, and it worked perfectly fine. And it was designed in a different way. I designed it from the sounds aspect. I didn't own a distortion analyzer at that time. And, some of the things that I believe in for good amplifier sound were I applied them, like no feedback and high power bandwidth, able to drive low impedance loads, and I worked on all those things. But I realized that if I made the amplifier the width that it was, and I didn't have an adequate heatsink, I couldn't make it work. So I started thinking about how copper worked and the fact that it absorbs heat 91% faster than aluminum, which is why everybody wants to use it for cookware. It's fast. Um, but that being said, I bought two quarter-inch pieces of copper and I put my output stage on it and I turned the amp on and I walked to the kitchen because this was all in the back room of my house. We had an office suite back there. So I walked to the kitchen to get a glass of water. When I came back, the amplifier was burned out. It broke. It was completely dead. And I said, wow, what happened? And I touched the copper and it actually burned my hand. So I said, wow, what is going on? So I checked the amplifier, rebuilt it, cooled everything down, turned it on again, and I realized that a quarter-inch copper was way too thin to do anything with. So then I decided to use a 1-inch piece because I know that uh, the thermal body of that piece and the mass of it would help me in dissipating heat and not overheating itself. And that was the magic because once I did a 1-inch piece, I realized that I can make this amplifier work with a 1-inch copper heatsink on the end. I did need to cool it, but I didn't want to put fins on it. I like the smooth size. So I thought I would drill holes in it and make them venturis like carburetors work and all that stuff where air flows from a smaller orifice to a bigger orifice naturally. And that worked out very well. And so that's how I cooled the amp. But I was totally into, after going to a bunch of different stores and listening to what they called their most musical, their best system in their store. And I came back with a conclusion that the stuff that I did at Krell, although it sounded pretty good, it wasn't as musical and satisfying musically as some of the other systems, which is why I took a completely different approach to how I designed the actual amplifier itself. Um, I did have to uh, keep myself in mind that I do want to be able to drive very complicated loads. So I needed a decent size output stage. But from there, I did an amplifier like I've never ever done at Krell. It was a totally different technique, totally different design, and it was challenging. But once I got it to work, I started to listen to it. I never listened to it, so I brought it into my living room, and Dave Wilson was kind enough to have loaned me a pair of Sashas, and I hooked it up and I listened to it, and I thought it sounded pretty good. But you get designer's ear when you're designing in a vacuum. So I had a couple audiophile friends who would come over and they'd listen with me. And they said, well, this could be better, that could be better. And we had this little, like, once a week that we'd get together and we'd listen to what I was doing. So they start bringing their stuff over and we listen to their stuff. We listened to my stuff. We listened to the Krells. We drank some wine. We ate some food and we had some fun. But every time the amplifier didn't measure up, I had it on two metal carts, and my living room was adjacent to my office. So I'd roll it in, make some changes, roll it back out, and we'd listen again. We did that for a while until I got it to a point where I thought it sounded as good or better than any of the other amplifiers, and better than what I thought was the best amplifier I had designed at Krell, the Evolution One, which was two stack amplifier, very nicely proportioned. That was a good sounding amp, the best one I think that we did at Krell sonically. And this amplifier was better than that for sure. And everybody agreed on that. So that's how we kind of got the momentum. Um, Along the lines, once I was kind of set with my circuit, I made some tweaks on it, and I was able to buy a distortion analyzer, got it, and I measured the amp, having never measured it. It didn't do badly. I made some adjustments and made it a little better. And yeah, it was, as I say, I'm very fond of saying I don't design for low distortion. I don't think there's any point in it as long as the amplifier is not doing anything stupid like overshoot on square waves and has a nice sinusoidal response all the way up to 100K. And so it did all those things. And I don't care if it was in point oh one, it was actually point 0.1. And it was very satisfying sonically. So that's where we kind of got started. And we went to the CES show, um, and I think it was 2013 because it just turned 13, and we built four amplifiers and we brought them to the show. But I'd like to tell you a story about how the amplifiers actually went together. Because as you can imagine, the case on the Momentum was really expensive and the copper was really expensive. So I had never had the amplifier in its actual case. It was always on flat perf boards on heat sinks. That's how I always listened to it because we didn't want to commit to buying the amplifier chassis and the heat sinks in a completely finished cosmetic form. So finally, when we did that, we bought four pieces. So because I was making monos, and I got them all working. Everything worked, all the boards. I mean, I had to teach myself how to lay boards out in CAD because at Krell, I had stopped laying out boards midway, and when CAD layout came in place, I had engineers to do that, and I never wanted to learn it. I'm from the old school where you put a piece of vellum down and you put tape on it, four times bigger than the board, and we taped it all together with different colored tapes representing top and bottom layers, and that's how I laid my boards out. And I was very good at doing that, but that's not how the modern world works. So once taught myself how to lay the boards out, we had real circuit boards, real metal that we ordered four pieces. It came in, and I put them all together. And if you've ever seen the Momentum, it's built it's built upside down. It's built, you turn the amplifier on its top and you build it from the bottom up so that there's no fasteners showing in the amplifier anywhere on the outside, the inside, they're all hidden inside the chassis. So I built the power supply and regulators and wired it all up, and I had the two heat sinks laying down on either side of the amplifier like wings. And I finally got to a point the next day, the FedEx guy was coming in the morning and they were going to get shipped out. And then Petra and I were going to get on a plane and fly to Las Vegas and put them in our room. Well, here it is, 2 o'clock in the afternoon, and I go to close one amplifier and I put the two copper heat sinks up and they wouldn't fit. They were just a little bit too big. And I realized it was because of the special um, coating that's on the copper and on the amplifier chassis. So I had a tolerance build up. So I couldn't figure out how to get the amplifier closed. So what I did is I let the amplifier chassis be cold and I put the heat sinks on it and it still wouldn't fit. I got it partially in, but I couldn't push them all the way in so I could put the bottom cover on. And time is going and going and going. Now it's like 6, 7 o'clock at night, and I still don't have one together. I've got it partially together, and the heat sinks are pushed up against the side. So I went in the garage and got carpenter clamps. You know, those crazy things with the cranks on them. So I got those and I got two of them and I put a cloth over the end that grabbed the sinks and I cranked it and nothing happened. So I'm kind of discouraged now, knowing that I'm going to have to take this absolutely gorgeous finish and grind some of it off so I could put the amplifier together. And I'm hoping I don't have to do it. And if I have to do it, I'm wondering how ugly it's going to be when I'm finished. So I cranked this thing and I cranked it really hard because I was kind of frustrated. Turned around, walked to the other side of the room to look at something, and all of a sudden I hear bang, they snapped in. And that's how I built those four. But it took a long time to get them all to fit. So, I mean, I didn't finish having those four amplifiers together until like 4 or 5 o'clock in the morning. So I had to leave in the morning and I had to pack those things. And again, as I told you, I'd never even picked these amplifiers up. I had no idea how much they weighed. They were so small that I was sure they were going to be a pleasure to pick up and pack. So, anyhow, I put the bottom on. I got ready to pick one up and carry it into the other room. So I had some room to pack it. And I realized they were 110 pounds and they weren't anything that I could just sling around. So I got them in the room. I cleaned them. I got them in. We shipped them in Pelican cases. And I got them all packed. I don't think it was till like 7 in the morning. And I think we were going to miss. I think we missed the FedEx pickup that we scheduled. So we had to put them in a car and drive them to a FedEx depot, and they shipped them to Las Vegas for pickup. That we had to go pick them up. So we finally got on a plane, and we got there, and we rented a truck, and we went to the FedEx depot and picked them up. Now we were in the Venetian. So the Venetian, the day before the show, you are not allowed to bring any equipment in any of the rooms. They're all locked up. You can get in your room, but you can't bring equipment in the room. The equipment's supposed to be in the room when they give you the room that day. So I realized that, hey, how do people know that I don't have my clothes in my Pelican case? So I got to the Venetian and we hired a busboy and he came and put those four amplifiers on one of those carts and he put them in our room. We got around that. That was fun. That was fun doing that because the rule was kind of a stupid rule anyhow. We're very we're very happy to be there. We had the the Wilsons there. We had our everything there. We had our preamp there. We had a little preamp that we put together that worked. So we played them. We had a DAC. So I had a nice sounding room, but was really surprising to me. We had two amplifiers on their stands on a floor when you walked in the room, and the Wilsons on either side of them. And we had two pedestals in the back of the room with a momentum on each one with a light on it so everybody could see it close up. So the day before, the day the show started, people would walk in and they'd say, "Well, where's the amplifier?" I said, "It's right here." They said, "Is this is just a mock-up, right?" Because they're expecting me to have a great big amplifier. And they were shocked to see that the momentum was actually quite small. And so we had a very nice show. We sold a lot of momentums, got a lot of people on board. And that's kind of how Dan D'Agostino Master Audio Systems got started. So uh, we we did that. We got back to Connecticut, and we had a bunch of orders. And I decided that I didn't want to stay in Connecticut anymore because I really got tired of the winters. And we had a particularly bad winter that year, and decided to go someplace warm. And my wife, who has relatives living in Arizona, decided that maybe we should go try Arizona for a little while because it would be warm, and she could see her relatives and her parents live here. So we did that. We moved to Arizona, and we got a little space, and we rented it, and we hired a few people, and some of the guys that worked for me in Connecticut actually came with us. We did get a very large order from one person in just before we left Connecticut, which was for 18 amplifiers. So we decided that not take the risk to build them just before we left. So we did build 18 amplifiers. We built more before that, but building 18 all at once. So I had this little crew of guys, three or four guys, and we put all 18 together. We tested them all. We boxed them all and put them on the moving truck to Arizona, which was a really good thing because it really took us longer than I thought to get ourselves set up in Arizona, but we finally did. And a couple of the guys that worked for me in Connecticut came to Arizona and lived here for a year to help me get started. And I do appreciate their efforts. And if they're listening, thank you. But anyhow, we set up shop in Arizona. We got the preamp going in production, and we start building some other things. We tried to build our lifestyle product, which was an integrated amplifier with a streamer in it. And we're a little bit early on the technology because the technology that we paid for wasn't really robust and kept on crashing on us. So we had some problems with that product out in the field with the streaming section, but we got that solved. And that's kind of how we got the company moved. The the rest of the product line, I always wanted to build what we call the relentless amplifier. I always wanted to build it. And I had this idea when I started this company, but I realized that it really had to be way bigger than the amplifier I did build. And I kind of had this kind of crazy schematic that I knew would work, but I had never made it work. So one of the things I did once we got our products going out the door, myself and another engineer that I hired out here who used to be the chief designer for Fender. His name is Bill Hughes, and he had just retired from Fender. And he drove up to my factory and he said, "Hey, are you looking for anyone? I'll do anything. I'll be a tech or whatever it is." So I said, "Well, he had MS and he was on a walker." And I said, "Bill, I don't think you'd do well as a tech because a lot of walking around." I said, "But you're an excellent engineer. Why don't we just work together on this project I want to do?" So he and I kind of put this circuit together, and we had a lot of arguments how things work, and we'd have some setbacks. and some successes on that circuit, and we kind of plowed through it. I think it took us almost a year to actually get it fully functioning. But it did exactly what I wanted it to do. It made an extremely large amplifier power-wise that was not an amplifier with feedback. It was a truly balanced amplifier with a circuit that gave us both sections on a single circuit. We have the negative and the positive sections of the circuit from a single differential input stage, which is very hard to do because on a differential stage, if you adjust the offset or DC on one stage, the opposite stage goes in the opposite direction. So there's no winning, just one. The other one goes the other way. So we had to make a circuit that we were able to make stable DC without affecting either side. And once we got that part working, we really have a really truly balanced amplifier that acts exactly like a balanced wire. So that's why because of that, we're able to build amplifiers that drive extremely low impedances and they're with a balanced output stage. So I think the Relentless 1600 is 1600 watts, maybe 1800 watts, and it drives any impedance all the way down to 1 ohm. And it doubles into every impedance if you have enough power coming out of the wall, which is a big challenge in a lot of places. But we built that and we sold a lot of those. And it happened that Dave Wilson had released the Wham around the same time. So that really launched Relentless for us. The Wham being really difficult to drive. Impedances vary from 8 ohms down to probably 1 ohm or below. And it was amazing when we hooked them together. But once I got the first pair of Relentless working, I had been corresponding with Dave, and I knew he had cancer, stage 4 cancer. And once I got that Relentless together, I was here in my little house in Cave Creek listening, and Petra said, "Don't you think you ought to call Dave and get the amplifiers up to him so he can hear them with you?" And I agreed with her, and I knew that things were tough for him. So I rented a truck, and a dealer friend of mine put them in the truck, and we drove them to Provo, it's probably a 11-hour trip from here, from Arizona. And I did that because I could have shipped them. Heidi, please, people are watching. Please, you can't be here. My dog is bothering me. Um, uh, I knew that time was critical. I was afraid to ship them because they're 700 pounds in their crate each, and I was afraid the shipping company wouldn't come through for me when I got there. So I didn't want to take the chance, so I drove them there. And when I got there, Dave had his whole crew. We put him into his listening room, and we hooked him up, and we listened, and he really had a big smile on his face. He was able to listen for about an hour, and then he had to return to his resting room where he was there. And it was really nice to sit with him for a while because we were very good friends. And I've been through all of his designs from the day he started, and he's been through all mine. And it was like a really wonderful thing to see him again and listen with him again. And we both kind of had a tear in his eye when he went upstairs. And I think a week later he died. And that's the story of the Relentless, how it got started. But since then, we have a lot of systems. I mean, plenty of Relentless systems with WAMs. And a lot of people have that system. It's amazing, absolutely astounding sounding. So that's kind of the story of the first Relentless. Along the lines, I wanted to build a smaller one because 700 pounds is a bit hefty to move for anyone. We move it in the factory with 6 guys to pack it. I wanted something a little smaller, and then I made the 800. The 800 is significantly smaller. It doesn't look it until you put it next to the Relentless, and then the Relentless kind of dwarfs it. But the 1600 looks just like the 800 looks just like a 1600, but it's smaller. I wouldn't say half, but a little less than, little more than half, but not double or not three quarters. Just a little more than half, and it's about 350 pounds, and three guys can move it and put it in a crate, which makes it much more portable. And we sell a lot of those too. Sell a lot of them with a variety of speakers. Um, the system I listen to at home is 800s and Wilson XVXs, and that's a very satisfying combination. Um, we designed a new preamp in the Relentless line, the Relentless preamp a few years ago. And those two things go in a lot of systems with Wilson, with Magico, with a lot of different speaker companies. I wanted to make an amplifier that was super musical, super powerful, and the Relentless is definitely that. And it was a journey to get it to work, and all that history with Dave, the stuff that we went through to make it work. So that's kind of where I'm going to start the next chapter of our story here. The Momentum, uh, 15 years after it was designed, was our biggest selling amplifier the whole time in our company. We sell a bunch of them every month for 15 years, and you guys all know high-end audio product, 3 years maybe if you're lucky. But we built that product for 15 years, and one of the reasons why it had longevity is because we believe that equipment we design shouldn't get obsolete. So if we come up with a new design, the 300 morphed into the 400, and we'd offered an update for guys who bought the original amps so they could have the same sound as the 400. And then along another few years went by, and we found another breakthrough in the Momentum when we made the Momentum MXV. And that was completely updatable. Even if you had the first pair of Momentums, we could make it to be an MXV. It wouldn't look exactly the same, but you'd have the sound. So that's one of the reasons why we did really well, and that product has really good longevity. And every product we build is pretty much updatable to whatever new standards we had. Product I didn't mention was a product that's kind of in the middle between Relentless and Momentum. It's below Momentum, and it's called the Progression line. And you notice I have this time theme, so that's why we call it Progression. So we made a preamp and two amplifiers, a stereo and a mono, and those were reasonably priced compared to the Momentum and of course, the uh, Relentless. So that product did really well for us. So now we have those three lines, and let's move up to January of this year. And I was doing some research a few months ago, I shouldn't say a few, about 8 months ago, with FETs, because back in the 80s, early 80s, FETs were available. You could buy FETs from Toshiba, and they had high current FETs with matched pairs, and they were available. And you could do some really wonderful things. And preamps, amplifier input stages with them are they were really fun to work with, but they discontinued them. And then there was no really good place, and there was no one else that was really making good FETs that were hi-fi quality and not noisy, and in matched pairs and in P channels. So I abandoned them. So we moved forward to now there's a Arizona company that moved to California that makes very, very high quality FETs, mostly for the military. And I think a lot of audio companies use them. But once I got them, I ordered some, and I start playing with them, and we made this little product called the Pendulum, and it has a FET front end, and it's an integrated amplifier that's 120 watts a channel, and it has a streamer in it, and it sells for a pretty reasonable price for us. Again, it's about $18,000, and it does everything, and it sounds amazing from this FET circuit. Has something to it that we all really liked. So I spent some time looking at it and realized that FETs have some limitations. They're all low voltage, nothing over 35 volts. So that makes kind of a problem for you when you want to build something really powerful. And was something we considered when we did the pendulum. That's why it's 120 watts. So that was basically one of its fallbacks. But we found a way to increase the power significantly. And we decided, after having made that leap into making a more powerful FET input stage, I started working on a new circuit for the momentum. But then we realized that what I had to do would not fit or accommodate in the original momentum box, even though the new one was bigger and it had better machining and more space. I could not do this in that box. So we decided that we would make the leap into making an amplifier that would replace the momentum, which we called the Momentum Z, which we launched this January. And it's a 500 watt plus. I mean, it's like clips at 550, 570. It's a very powerful amplifier. But unlike any of our other amplifiers, it has a fully regulated output stage. Now that's unusual in the audio community because a lot of people, including myself at Krell, because one of our amplifiers was fully regulated and it sounded really good at the time. But then we made some amplifiers after that weren't, and we kind of liked what that did more than the regulated amplifier. And of course, the advantages of the regulator are the fact that if let's say you have 50 volts at the output stage at 8 ohms, you go to 4 ohms, you still have 50 volts. You go to 2 ohms, you still have 50 volts, which is not, you cannot say that with any amplifier that's not regulated. So in order to get your amplifier to double into the next lowest impedance, you have to have a little more voltage than you need at 8 ohms to make 4 ohms double and to make 2 ohms double. But the voltage at the output drastically drops each time you reduce the impedance. But this is something that's happening all the time when you're playing music. So in reality, if you didn't have to, you wouldn't have an amplifier that's not regulated. What are the advantages? Well, you have big filter caps, so they spring back, and you get a thing like call it a crest factor. You get a little more output at a peak because it's just for a short time, but it's there. And that makes the amplifier in some ways sound more musical than a regulated amplifier. So I decided that the reason for that, and in all reality, any other thing that you were doing, the regulated amplifier would be superior. And they all measure, it measures better, all those things. But how do I get it to sound as good as it did unregulated? And I started to realize what the problem was when I was designing it. The regulated amplifier, the regulator itself has to be significantly faster than the amplifier. And what we did at Krell, we made the regulator and the amplifier with the same parts. So regulator couldn't be any faster than the amplifier. So there's a lot of new parts out there, obviously for electric cars and things like that require this kind of function. And I start using those parts, and I made a regulator that was significantly faster than my amplifier. Once that was accomplished, putting them together was a treat, was amazing sounding. Play it without the regulator with big filter caps, play it with the regulator, and 100% of the audiophiles are going to pick the regulator, 100%, because it has more authority. It's much better at low levels. It's super quiet. Um, unflappable basically in any load down to 1 ohm, which is a wonderful thing. And as you know, speaker impedances go all over the map. And I always have this funny saying that we used to talk about at Krell: if you can't drive low impedances, your speaker is actually dictating to your amplifier how it's going to sound, when it should be the other way around, when the amplifier should have total control over the speaker. So in a lot of amplifiers, impedance dips, the amplifier's output stage dips, the input stage dip. So everything changes. But the regulated amplifier, none of that happens. So consequently, if you guys get out to hear a pair of these at one of our dealers, have them play it at low levels. And I promise you'll be shocked, because you're going to hear all of the bass, all of the top at the really minuscule levels. They're all there. And that's something a regulator can do. And then at loud levels, you don't have the soundstage collapsing. You don't have any anomalies associated with amplifier output stages with the regulator. It completely controls all of that. So that's our next step. We call it the Z system, and there will be some more coming later on. But we're really, really happy with the Z amplifier. It's been a amazing presentation. We did a release party in January, and we had people from all over the world come to our factory and show them how it's built and what it does. And we listened to it, had a big party. Everybody really enjoyed it and really liked it, thought it was definitely an advancement. And we feel it is too. So we're gonna continue to pursue that technology. And again, there will be updates for other amplifiers and preamps to embrace that technology as we develop them. So that's kind of where my story is stopping right now. So I can tell this is how this company got started, and you know the history of me at Krell, which I think I've talked about it a lot. I think everybody knows. It's been all over the internet. And unless you guys have some specific questions for me about it, you guys all know the history. So I think that's where I'm at right now. So if you guys want to break, you want to have a question and answer, I'm ready.
That's great. Thank you, Dan. I'll put us on pause, and good. We're here. I noticed that Mike asked a question in the chat. You may be able to see some of those. You don't have to read them all, but you can, if you can see I think he was first. Could you pick that up?
Okay,
Or we can ask.
oh, okay. When you listen to new prototypes, what specific sonic qualities tell you you are on the right track? Any specific pieces of music you use regularly? Well, I listen for detail in the background. I'm always trying to get the most out of my recordings. I mean, when I have a new technology, a new circuit that lets me see or peel some layers off the onion, as some people say, I want to be back there. I want to hear it. I listened to a couple Billie Holiday tunes they were recorded in the 50s. Um, and when she was popular in the 50s, you got to think that her studio musicians must have been kind of the best guys out there to back her up. But because of microphone technology, and they kind of push them into the background. And I keep on trying to hear them. And some of the later things that I've done, like the Momentum Z, I can actually see and hear those guys back there playing, just way back there in the background. I can hear their riffs and their changes. Makes me very happy, gives me goosebumps. I love that, that I'm able to do that. But that's what I listen for. I try to get into more of the detail in the background of the recordings. So I figure when I can hear that, the rest of the things fall in place. I'm really jazz nut, so and I like that, but I listen to rock and I listen to classical and I listen to all sorts of things. But I'm into how much information can I get out of the recording? What's really there, and can I get it all? The answer is I have a lot of it. I'm not sure I'm getting it all yet. And the harder I work, the closer I get to that point. And let's see, I got another question on the chat from Don Ruckoff. Is a choke the same thing as a regulator? Well, it's similar. The difference between a choke and a regulator is that a choke will not change. I mean, its electrical properties are an instant change. If something changes immediately on a choke, it doesn't let it happen. It resists it. But it only resists it for a period of time until the source or the reservoir that's charging the choke starts to run out of power itself. A regulator stays that way all the time, regardless. So that's kind of the difference. But a choke is a really good power supply and difficult in most audio amplifiers because of the amount of room that it takes. Because if you have a giant transformer, you have a giant choke. I mean, it's takes up a lot of room, which is probably why a lot of the designers don't do that, don't use it. But it is a good format because it does work very well, by the way.
Hey, Chip, why don't you read the questions for Dan?
Hey, Dan, I have a couple here for you. You didn't say much about your preamps. Do you design those as well?
Oh yeah, I
And
do.
what is your special sauce for in that design?
Well, in the first preamp I designed, I got when I left Krell, we were doing a lot of Kurt mode design, and when I designed the preamp for the Momentum, um, I stuck with current mode designing, and I love the way it sounds and the fact that it has no real voltage gain stages. The end of the circuit is the gain stage through an I to V converter usually. But I'm really the preamp for me has to be quiet, functional, and give me some more space that I couldn't get. For instance, if I put a really good DAC on my amplifier and I play it, and then I put my preamp on, well, I want it to sound the same, but if I don't get more space and more depth and more transparency with the preamp, then my preamp's not doing a good job. I think if you put your preamp in and the sound changes, then it's not doing a good job. The sound should stay the same, but the atmosphere around the sound, the depth, the field, the transients, the noise floor, all should be better with a good preamp. So that's the stuff I design for my preamp. I'm very finicky about volume controls. I don't like potentiometers. I don't like steppers. So I designed a not an R to R network, but a basically linear uh, uh, ladder supply volume control. So it's a bunch of different value precision resistors that are selected by a gold-plated relay, so there's no line lost. And it selects different resistor values to make the RA, not the RA curve, but the logarithmic curve for a volume control. So the volume control is a very important factor for us. I mean, I wish I could get around it another way, but turns out to be an extremely expensive part of my preamp because of the relays and the fact that I have to have these 0.01% resistors that I use that are ridiculously pricey as you go down in impedance or down in value. So that's something I'm very finicky with. Plus, the output stage of our preamps is really one of the magic because we use a real it's like a miniature amplifier with way more bandwidth than an output stage because we're using really fast transistors, output transistors. Even the fastest ones aren't that fast compared to small signal. So those two things. Preamps usually have a internal supply that's in another box. All of my preamps have that because I don't want the regulator or any noisy parts in with the audio circuitry. Um, I always make my preamps modular. So if you have two-channel preamp, you have two channels. Each channel consists of an input, a volume control, and an output. And so they're all discrete boards that plug into a mother base so that when I want to make updates or I want to change, I can just pull them out and plug them in. So that's a lot of the stuff we do with our preamps, and all of them are differential technologies because we strongly believe in balanced outputs and inputs, and we want someone to be able to get those benefits even if they use a single-ended. So if you put a single-ended source into my preamp, it'll automatically drive both phases because of the differential input, and you get balanced again all over, even though you're using single-ended on the input, because I think it's an extremely important facet.
Thanks. The next technology question, are there new output devices you cited using gallium nitride? Or if not, have you looked at them for your equipment?
I have looked at them, but there are not too many of them that will satisfy the current needs. And as soon as they get that down, which the problem is that technology in audio, I don't think that the companies making those devices are thinking about audio companies. I mean, maybe they will get around to thinking about us, and then they'll say, "Oh, let's give them some high current, super fast devices," which will make a whole lot of sense if we could get them. They'd be a lot of fun, but I haven't seen any that can actually be part of an output stage. And I might be just not informed. There might be some out there, but last time I looked, which just a little while ago, there wasn't.
You said that amps with balanced inputs sound better. Do they also measure better?
Yes, because if you take noise into a consideration, they will always measure better.
Don says, did I go deaf? I'm not sure what he means by that.
Okay. Um,
Let's see, I think I've covered all of these. That anybody else that I've missed would like to say something, please unmute right now. Okay, um, everybody, this is Q&A. We've asked a few questions. We've got Dan warmed up. He's ready. He's still ready to go for a little while. Could you please unmute everybody who would like to speak? Remember to remute after you have spoken. Go ahead.
I'll chime in. I hope I don't hit any triggers on you, but have you ever considered doing hybrid amplifiers with tube input stages?
I don't like tubes. I designed with tubes when I was 14, and I'm really not interested in what they do in any level. I find them. I mean, as an input stage for a preamp, they're very good. I can't say they're not. They sound good. They work well. The amplifiers, I just can't. I can't deal with so much of the audio spectrum missing. So I don't like them, but I do like. I mean, I could see myself making a tube preamp, but I couldn't see myself making a tube amplifier.
Dan, this is Mike. What's in your streamer? What kind of DAC technology are you using in your streamer?
Well, right now we're using off-the-shelf parts for our DAC. We're using ESS parts in a number of different ways, and we get pretty good results with them. I'm not trying to be in the DAC business, but when you make a streamer, when you make an integrated amp that people want a streamer, we find ourselves having to do that because some of the people that I admire in the DAC business are not interested in licensing us their technology because that would be kind of cutting their own rope, you know what I mean? They have their own technologies and they market it with their products. So we use off the shelf DACs, but we're very fond of the ESS product. Uh, Down the road, we may try to do something more adventurous. Because as you know, I did have a company called Krell Digital where we did make our own DACs, and they were pretty good for the time. I'm not willing to dive into that right now. I have too many other things in the audio analog domain that I'm working on, but um, I think by necessity we needed to have a DAC and a streaming technology in our integrated amps because people really like that, particularly an integrated amp. It's one of the reasons you buy an integrated amp, so you could have a one piece solution. You've got a preamp, amplifier, and streamer all in one box. So all you need is a pair of speakers. And our product, like our pendulum, fully loaded with a DAC, it has a really good moving coil input if you want to use a cartridge. So you can do everything with it. I mean, and that's the beauty of a really good integrated amplifier. It does everything very well. Doesn't have to do everything exemplary like separates, but it does it all very well. And that's the genesis of a integrated. I mean, our momentum integrated uses exactly the same circuits as the momentum preamp and the momentum amplifier. So it's really not a compromise. It's just all in one box. Yes, sir. Doug?
So,
Don?
Mike, this is Mike again. Uh, about your power supplies, can you tell us a little bit more about what technology you're using of those? Are you using switchers at all, or?
No, we don't believe in switchers. We use really our own design transformers, which are very complicated and expensive. And we use analog. I don't like the sound of switching supplies. I have a fly killing me here. But I don't like the sound of switching. I can always pick them out. Always. You play an amplifier for me with a switching supply, and I'll tell you whether it's a switcher or not.
You mentioned FETs that you were using. They weren't quite high enough power for you initially.
Yes,
Do
yeah.
you use
Go ahead.
JFETs or any other type of FET?
No,
And
we're using JFETs in our front end. All the other ones are a little bit too noisy.
what about MOSFETs?
MOSFETs are good more in a power application and some other applications, but I'm not using any MOSFETs currently.
So just JFETs.
Yep, that's right.
Dan, this is Jay Knight. I don't know if you can hear me.
I can hear you.
I have a pair of Sasha DAWs, and I'm thinking about upgrading the amplifier. And what you said about the Z amp, I'm sitting here wondering, A, should I wait a little bit and see, or would you recommend one of your amps right now for those speakers?
Well, the Z works extremely well with Sasha's. I mean, extremely well. It also works extremely well with XBXs because it's got so much power. It works great with all of the Wilson products, and I've heard it with a few other products that it works really well with, like Magico and that. But I don't think I would steer you wrong if I told you it would be a fabulous amplifier for your Sashas because it would.
Okay.
Can I ask a real simple question? What's the least expensive power amp that you make now?
Currently, the least expensive power amp I make that's still in production is the Progression Stereo, which I believe is $25,000.
Are you planning to have the Z amp on display at Expona?
Yes, it will be there for
Good.
sure. It'll be with our dealer in Quintessence. We'll have it. And I think another speaker manufacturer will have it, but I'm not at liberty to mention yet.
Who are your dealers in Southern California?
Well, I have Brian Burdan. I have Meyer at Santa, no, not Santa Barbara. What's he at?
He's in Culver
He's
City.
Yeah, yeah. And who else do we have? I'm not really knowing all of our dealers. I know them by name, I know them personally, but I mostly don't remember their store names. So Audio Salon, I think, is Meyer's store. Um, and who else do we have? We have one other one that, and I hope if they're listening, you don't get mad at me because I don't remember the name of your dealership. But anyhow,
Do
we
you
have.
have do you have Mission in Santa Barbara? That
I don't
sound
know.
familiar?
It does not sound familiar, but we might. I'm kind of a lab rat at 79 years old. So I go in my factory and I go in a lab and I have my 4 or 5 engineers and we try to design new products and we're hopefully that there's something people want to buy. And I think with my experience of listening and the hardware we're doing, I think we're doing a pretty good job, but I'm not on the sales force or the marketing force. So I try to learn as much about it as I can, but my time is also taken up the whole day with designing things.
I can speak that you're a busy man. I do have one other question for you. If you'd give one piece of advice to a young engineer entering the high-end audio field, what would that piece of advice be?
Come and apply. I'd love to have you come and work with us. Hopefully
Oh,
teach you something. Maybe not. Maybe you'll teach me something. But any young engineer that wants to come to work for us, we're willing to listen and see if we fit together.
A lot of companies having staffing problems these days with the older technologies. Do you anticipate that to continue, where it's
I
harder and
do.
harder to get
I
things repaired?
absolutely, I absolutely do. I mean, a lot of analog engineering isn't even being taught in electrical engineering right now. And we had a few applicants, and I'm not going to name the schools, that actually had no idea about analog engineering, and they wanted to work in audio, or maybe they just wanted a job. I don't know, but we found that we didn't really speak the same language.
Dan, it's Kurt Youngs. Your California dealers are Audio Element in Carlsbad,
Yep,
California, Alma Audio in San Diego,
right.
Audio Salon in Santa Monica, Excel Audio in Newport Beach, and Audio Element in Pasadena.
Oh, well, there you go. I remember all those names now that you mention them.
Hey, as a happy owner of your Pendulum integrated, do you have any expectation of doing more trickle down development down to the price range of the Pendulum?
I do. I actually am working on some stuff for the future and in that product line. So yeah, there will be some stuff coming out in that area.
So this is Mike again. You kind of portrayed that you started from the chassis and then you put the electronics in it.
Yeah,
Uh, so tell us a little bit more about how those chassis are made. They're very impressive
yeah,
looking.
they're made from a solid block of aluminum. and they cut out the chassis. And it's a nice thing because everything's quite precision. There's no parts to fit, and it's look and feel when you pick it up. It has a substance and quality that really rings of high precision.
I guess following his Mike's question, is all the casework done in your factory?
No, we do no metal work.
Okay.
We do some metal work in Arizona. We do some metal work in Colorado, various places. And we we're not a metal shop. I always wanted to do metal, but some of the stuff that we're designing right now, I would have to buy new machines for. That's for sure. And working with copper is no picnic for a machine shop. You need special machines to actually cut it, process it in a way where it could be finished so it looks beautiful.
Must admit, the first time I saw your equipment at Munich, that I was impressed with the amazing size of it, number one,
Yeah.
and number two, how pretty it was.
Yeah.
It has its own version of just perfect.
Thank you. Thank you. It's very nice for you to say that.
Where do you get those meters?
Actually, that's the one part that we constantly have to buy from a foreign source. We buy them from Taiwan. And then we take them apart and we put I'm fascinated with watch movements, so I try to make them look like a watch movement. I put little bridges on them, copper parts, so I get to take the meter apart and adapt it to what I'm doing in each product. We use a couple different meters. We use a 270-degree meter, and we use a 90-degree meter. We use and the actual wand on the meter is a knockoff of a wand made by a watch company called Breguet. But I don't make the exact look. It's similar, not exact. But I've always liked meters. And I mean, I know that in reality they're throwback to the old days in audio, but I think that's probably why I like them.
No argument here.
From a performance point of view, what do you think the chassis contributes? Shielding and vibration resistance and things like that.
I think it contributes quite a bit, particularly when you add copper to it, whose uh, uh, mass is so much greater than aluminum. When you couple them together, it really takes all the resonance and vibration out of a chassis. But a solid chassis is a wonderful thing because on all of our products, the chassis and the ground are the same thing. So it's not a little metal part that's got a ground, your circuit ground and your chassis ground to it. The chassis is actually the ground. So I think that's important. I feel like the impedance of the ground has to be very low. So I do use the chassis as the ground. So it's a big ground.
Speaking about the grounds, do you implement a ground connection on your chassis?
No, I don't. I don't believe in it. I think that when you ground all the parts together, you obviously are going to have things that are. What would you do? I mean, where does it stop? I mean, if you look at, I've looked at 100,000 audio designs. A lot of people put a 5 ohm or 10 ohm resistor to their chassis ground, and vacuum tubes, very common. How do you hook my chassis to that? Where the output stage is at the output is at earth ground and the chassis is at earth ground, and now you're going to hook up something that's 10 ohms above ground to the same chassis and draw current. through my electronics. I wonder why you want to do that, why I would want you to do that. There's no benefit to that. And anybody that tells you that they're a benefit is 100% wrong.
I was thinking in terms of the preponderance of special grounding boxes that we're finding in
Yeah,
the hobby today. Is that what you're
that's
talking about
exactly
there?
what I'm talking about. I'll bet you if you took a really sensitive gigahertz scope and you touched it to that box on its own and then hooked all your equipment up to it, you're going to find noise in every spectrum that you don't even believe exists. And it's going to be pervasive through every component you hook to it. So I tell people, don't ground my amplifier to any box. You plug it in the wall, the ground that your house ground supplies you, you should have checked if you're worried about it. Because I live in Arizona, we don't have a really good earth ground. You got to put a big 12-foot copper bar in the earth to get a ground here. I know I've gone through that. And a lot of people live in houses that aren't new, so the ground connection to earth ground outside, I wouldn't trust it. I think they're probably not so great. I mean, a lot of people put hook systems up, say, oh, I got hum. I said, you're using two different ground paths. One takes a long wire to the ground, and then the box isn't grounded right. And that, I mean, those are all things that you have to look at when you have a really high resolution system. So I think hooking everything to a ground box, and I mean, not everybody understands what the grounding is in their equipment. And then they hook it up to equipment that is grounded correctly. I don't think it could help the overall sound or anything.
You like a little history? Talk a little bit about your early career and when you decided that audio was going to be something you wanted to devote your interest to.
You want to know the thing that really tripped me over for audio, to want to be an audio guy? I was really into, when I was 11 or 12, my father was an audiophile. He was a tool and die maker for Bell Aerospace. And he was really into music and audio and used to read all the old books in the 50s, which I used to look at. I was so interested in the Olson and the Allied catalogs. I'd go through them and read the specs and all that gear. And I really always liked audio. But when I did do some design work for other companies, but the really thing that really wanted that I really got me going in audio was the Mark Levinson ML2, which was 20, they claimed was 25 watts Class A. And I remember it was like 1978 or 77. I walked into Lyric Hi-Fi in Manhattan because I was an audiophile. I'd go in every audio store and see what was cool. And he always had some really neat things. And I didn't know much about the Mark Levinson company. I know it was a good brand, but I didn't know much about it. So I went in there and he had a pair of Mark Levinson ML2s, which are 25 watts Class A in the floor. And I went up and touched them, and they were the regulator section of it was super hot, and it was just a hot amplifier. And I said, "Can I hear it?" And he hemmed and hawed, and he said, "Sure." And he hooked it up to a pair of clip shorts, which they're not a bad speaker. I mean, my dad had Klipsch corner horns that he built himself. They used to be able to buy a kit in the 50s, and you could turn that over. You can get the plans for building a Klipsch corner horn and give it to your favorite carpenter, and he make the box, and you can put everything together. And that's what he did because he wasn't an engineer, but he bought an integrated amplifier from Lafayette Radio, and we played music, and the Klipsch horns were amazing back then because there was just nothing around. And I think that was a marvelous speaker for the time it was made. But, looking at all the crazy speakers that were out in the 70s, late 70s, and a 25-watt Class A amplifier when the average speaker was 86 dBs for 1 watt in, which is pretty inefficient by today's standards. Uh, but he played Klipschorns, and it was a pleasant sound, but hard for me to get a bearing, when I was trying to listen to many of the other new style speakers that were out. And so I started thinking, I went to the CES show in Chicago that year, and I walked around, and there was a lot of people talking about Class A amps that were sliding bias. And I didn't want to do that. And I wasn't impressed. Um, but I always wanted to say I wanted to make, after listening and looking at that Mark Levinson amp, I said, well, why couldn't someone just make a 100-watt Class A amplifier? It was kind of something on my mind. And so I started to think about it, and I actually put something together, and I used a fan and got about 75 watts Class A in my little apartment in New York City on a coffee table, and it kind of sounded really good. And I went to a hardware store and they still sold big chassis and stuff in the hardware store in New York City. They had like metal boxes. So I put the whole thing on top of this metal box. And I was friends with Peter Axel from the Audio Critic. You guys remember that? The Audio Critic magazine.
Mm.
So I brought it to him and I let him listen to it. He goes, "Wow, that is amazing sounding." I said, "What do you think?" He said, "Well, how does it work?" I told him it was Class A to 75 watts. And wow, that is amazing sounding. And then I started thinking, it's got to be 100 watts. I think it really had to be 100 watts. So that wasn't too hard to do. But I was going through I'm trying to figure out how to cool it. And I came up with, I guess, not a novel idea for industry, but a novel idea for audio was I put a fan on a tunnel that was made for a fan, and I blew a very slow moving fan. I adjusted it a very slow volume to blow the heat down instead of up, because your normal idea was to blow it up, but then you would have the noise of the fan amplified through the fins of the heatsink. So I figured I would just blow it down so it would go onto the floor and you wouldn't hear it as well, which is what happened. So I did make a 100-watt Class A amp, and it was really kind of a tour de force for the time. It had two 16 kVA transformers, 200,000 microfarads capacitors on each channel, a stereo amp, and it was Class 8, 100 watts. I didn't even measure it any way. I just put a current probe on the rail, and I I looked at the signal and the oscilloscope and adjusted the bias so the current and voltage looked exactly the same, which is the true uh, definition of Class A. It never shifts its bias out of Class A mode. And it sounded great. And I put those together kind of like I did the Momentum. I told you that story about getting him to the CES show. The Krell was exactly the same thing. And I got the name Krell because when I hooked it up to the current speakers, and there were some really inefficient things like Ohm F and stuff, Ohm Fs that I hooked it up to, it really drove them. So I started to think, wow, this amplifier really has this grip. Sounds like it's got unlimited power. What kind of name could I come up with it? I didn't want to put my name on it because I was afraid the company would fail because it's a new company and a new venture. I didn't know if I could keep it in a business, and I didn't want to have a company with my name on it going out of business. So I tried to find a name, and I couldn't think of a name. And I was I was a sci-fi buff, and I always started to think about crazy power things. And I thought about the movie Krell, because the Krell, if you listen to the legend in the movie, were beings that possessed unlimited power through their machines. So I said Krell would be a great name, and that's why I named it Krell. So that's kind of how that got started.
As a sci-fi guy, I relate. Thank you for sharing that.
Yeah. You know, a little caveat to that story. Many years later, in the early 90s, I was at the CES show in Las Vegas, and this guy walks in and he said, nice, Krell. Nice name, nice name. He said, by the way, I'm the guy who made the robot, and I have a working model of it in my hotel room here. Would you like to see it? I said, yeah. So I went up to his hotel room and he had it hooked up and made it do a few things, and it moved around. It didn't move, but the things on the arms that whirled, and the voice thing whirled with the blue light in it. And I said, wow, that is really cool. He said, you want to buy it? And I said, how much is it? He said, $35,000. And I said, wow, I do want to buy it. But I left the room and I went and talked to my sales guys, and I had a marketing guy there that was a really great guy and a real great friend of mine. His name was Mike Detmer, and he said, Dan, I understand why you want that robot. He said, but if you bring that robot to a show, everybody's going to talk about the robot and they're not going to talk about your product. And I didn't want to take that to heart, but after I thought about it a few minutes, I said, I really want that robot, but you're right. You're just right, and so I didn't get it, but that was a very tempting thing.
Well, we've just passed 3:30 here, 4:30 your place. I promised you to get you to dinner early rather than late. But
Actually, Chip,
do you
guess
have
what?
some questions for us?
We're at the same time now.
Oh,
Daylight
good.
saving time happened today.
Oh, good. Okay, that makes it a lot easier.
Yeah.
I can keep you the rest of the afternoon. It's not a
Oh,
problem.
please don't.
Can we call it a day on the Q&A session and just go into general discussion? It's about that time. Anybody last question you want to get in?
Yeah, Dan, do you miss the Buffalo Wild Wings from Buffalo, New York?
Absolutely. Absolutely. That was a great place to live at the time. But I left there early, and I remember, that's a funny story. I remember getting drafted and stopping at the Anchor Bar, which was outside of the train station that I had to take to Chicago to go to Navy boot camp. And they just had started making chicken wings at that time. I had some, I didn't think much about it, and then that started to get very popular. So that was an interesting time.
Okay, last call, please. We're going to stop the recording and go to general session right now.